equals, which function prime is this? So it's 3 natural log of x, of absolute value of x, plus x to the third over 3 minus x to the fifth over 5 plus a constant c. When I differentiate this, I get that. When I differentiate this, I get this. When I differentiate this, I get this. When I differentiate c, I get 0. Now I'm told that y is -4 whenever x is 1. But when x is 1, natural log is 0. This is 1/3. This is 1/5 plus a constant c. So now I move everything to the other side and I find c. So c equals -4 minus 1/3 and plus 1/5. The least common denominator is 15. This needs a 15, this one needs a 5, and this one needs a 3. So -60 minus 5 and plus 3. -2, so -62 divided by 15. I have to go and, I have to go and put it back. So then y equals 3 natural log of the absolute value of x plus x to the third over 3 minus x to the fifth over 5 minus 62 over 15. And this is it. Any questions? Now, the next set. They're not asking us to solve. At this point, they're trying to ease us slowly but surely into solving, but we're not there yet. So, 7, we are given a differential equation and we're asked, is this or that a solution? And 8, the same thing. In 9, show that this is a solution of the differential equation. Show that this is a solution of the differential equation. The same thing. And the same thing for 13, 14. Anyone would like to choose?
Can you do number 7?
Yes, let's start with number 7. In number 7, we are given y prime plus 4y equals 0. Show that y equals e to -4x is a solution of the differential equation given above. Okay, so all I have to do, this I have, it's e to -4x, but I do not have the derivative. So I have to find the derivative. E to a function prime is e to that function times the inner function prime. So the derivative is -4e to -4x. Now, I replace this by what I just determined. I replace this by the original function. If I get 0, I will say yes. This is a solution. If I don't get 0, I will say no. This is not a solution. Okay, so let's plug it in. So y prime, -4 e to -4x plus 4 multiplied by y. If this equals 0, I'll say yes. If this doesn't equal 0, I'll say no. What will you say? Would you say yes? Or would you say no? Anyone? Will you say yes or will you say no? Meaning, does this equal 0? If it does, then I'll say yes. that is a solution. If you say no, then I'll have to say no, it's not a solution.
Say yes.
Oh, of course, yes. It is. Because this is indeed 0. So I put the derivative of the function, then I added 4 multiplied by the function. I did get 0. So I will say yes, this is one of the solutions. It may not be the only one, but it's definitely one of them. In part B, show now that a general function, as you see, the same function but with some constant in front, is a solution where C is any constant. Okay. So now they're asking us to try C e to negative 4x to see if this one is a solution. Well, I need to find the derivative. But the derivative is not going to be any different. There is just, they are throwing a C in there for us. It's the same thing, and C is there. And now I have to plug it in. So negative 4C e to negative 4x plus 4C e to negative 4x. Does this equal 0? If you say yes, I will say yes. If you say no, I have to say no. What will you say? Does this? Yes, of course. So I will say yes, indeed. Good. I think we have time for one more. Anyone, please? Or I will choose.
Can we do 10?
Yes. I was just looking at 9. 10 is good too. In 10 we have y equals x natural log x plus 3x minus 2. And the differential equation is the second derivative of y minus 1 over x equals 0. Okay. So let's see if this is the case. In order to find the second derivative, I have to find the first derivative first. So, y prime. This is a product. Careful. First function prime times the second one plus the first times the second one prime and plus 3. So natural log plus 4. Now I can find the second derivative. But the second derivative is just 1 over x. All I have to do is just plug it in here, subtract 1 over x, and see if I get 0. If I get 0, I'll say yes. It's a solution. If I don't get 0, I'll say no. So, is 1 over x minus 1 over x 0? If you say yes, I'll say this is one of the solutions. If you say no, then it's not.
Yes.
Yes, of course, this is true. So this is yes. X natural log x plus 3x minus 2 is one of the solutions of the differential equation. We checked. We found the first derivative. We found the second derivative. We plugged it in. There is nowhere to plug in the first derivative. But I had to find it because otherwise I can't find the second derivative. So the equation is only the second derivative minus 1 over x. Fine. When I plugged it in, I got 1 over x minus 1 over x, which is 0. Therefore, I have to accept or say this function is one of the solutions of this differential equation. There may be others. I don't know. But definitely this is one of them because it verifies the equation. This function verifies the differential equation. So that must be a solution. So when we solve differential equations, we find functions that verify the given differential equation.